so people can come in. There we go. All right. So one of the things in research that, when I was saying the stats is not the most accurate thing, but very precise. And one of the concepts that people need to understand is that research never proves anything. So I think maybe it was in this week that came up. And the reason research doesn't prove anything is simply because of that thing called an alpha level. If you remember the alpha level, that's that determining area, usually defaults to 0.05, that a researcher is willing to accept a type 1 error. And a type 1 error basically is rejecting null hypothesis when the null hypothesis is true. So if you have 5% of the time where you could make an incorrect conclusion based upon some extraneous variables, then how can you prove anything? Okay, because 95% of the time you could be right, but 5% of the time you could be wrong. So really it doesn't prove anything. It just supports or fails to support your hypothesis. So actually how this all started, and I'm going to give you a quick background as people are still coming on. Back in 1992, oh my gosh, 1992. Remember that far back? 92, 2002, 20-some odd years ago. God, it didn't seem that far, but I tell you how far back it was. 1992, I did actually my first consulting job for a business. It was with Wilson Sporting Goods Company. That's when John Daly won his first major as a pro. So anyway, in 92, I was teaching, actually in 1990, I was teaching statistics for Arkansas State University. And I'd walk into a classroom and I'd say, okay, here's what we got. What are the questions that you have? And one of them stood up and says, well, why doesn't, I read the chapter and I don't understand anything. Why can't they write so we can understand it? And I said, that's because most of the stat books are written by psychologists to try to impress other psychologists. They're not written for stat students. So when I'm, so I went through the process and explained it. I said, well, this is all the person is saying. And so the students would ask me, why did he just say that? And I went, yeah, why didn't he? So what I did was I wound up teaching class and I'd go up to my office and I'd write the chapter. So by the time the semester was done, I had the makings of the book and I just started refining it. And by 92, I had the first publication of it. And it was well received for a lot of different places because it was actually written for students to understand. And so it was called A Statistical Journey, Taming of the Skew. And I had a little guy called Cyrano Stat who'd run around in his little cape and sword and point at stuff all the way through. So it was kind of a neat concept. And then I kind of grew up a little bit and I modified it, took out Cyrano. And then I just started talking to people, more through the book and trying to explain it. So that's how this book came around, because my goal is to not to try to confuse people, but to try to make stats easier to understand, because at the doctoral level, you're truly going to have to use this terminology. That's why I call, it's a new language. It's called StatMe's. And, it is something that is totally different from people. And I had a webinar last night dealing with quantitative methodology. So I think you have a required webinars that you're going to have to take coming up. So I have quantitative methodology I do, then I have one that's reliability and validity. But in this whole thing, one of the questions that came up, and he says, what advice do you have for your doctor, to get along with your doctoral committee? And I said, my advice is don't come in with an attitude, okay? Because you're going to be disillusioned by the topic you want to do and what you're able to do. And that's where the attitudes come in, because this is my passion. This is what I want to do. And okay, well, that's really fine and dandy, but you have to understand there's 6 criteria for a dissertation topic in a quantitative sense. One, it has to be measurable. You have to be able to measure in some form or fashion. It has to be manageable. You can't have something so convoluted that you're going to have so much data that you can't read it and understand it. It has to be applicable. In other words, it has to answer a question that identifies a gap in the literature. It has to be acceptable. It's something you're going to have that's got to be accepted by the research community as something that's relevant and gives some credibility to what's going on. It has to be doable. In other words, people have passions on doing something that's doable, but come to find out it is so complex you're never going to get enough sample size in order to properly analyze it. And last one, it's got to be defensible. Last place you want to be as a researcher is on the defense on any of your presentations, because it's not a pretty sight to be. So that's the credibility and the believability of being a researcher. So in this whole realm of where we are in week 8 is the 7-step process. You are actually conducting a hypothesis test. And this is the first step of understanding how this stuff works. And so that's why back in when I actually originally wrote the book in 90, that I put in the 7-step process, because people need to be focused on what they need to be doing in an order of which they need to do it. And so that's why I included the 7-step process in this, and I try to make it very excuse me, critical to understand that you need to include the 7-step process in the assignment. Otherwise it comes back to you and you're going to have to do it again. So very important to understand how this process works and why it's there. So, we start looking at it in what you've read this week. We're looking at a 1-sample Z-test and a T-test. And basically they're the same water, different jar type things. So the only difference between the two is that one has a known standard deviation and the other one doesn't. The Z-test, if you have 1 sample and you're comparing it to an established norm, which is 1-sample test, you're going to be given the population mean and the population standard deviation, of which you work by. If you're given the population mean but no standard deviation, you're going to have to calculate the standard deviation from the sample, okay? And you have to use that. That's the estimated standard deviation. And so you use that estimate as the standard deviation with the assumption that this would generalize into the population standard deviation. And then you perform what's called the t-test, student's t-test. And what it does is allows for that margin of estimation because of the test being robust. And robust in a statistical sense means the power of a statistical procedure to perform its function against any minor violations of assumptions. Right? So having to estimate your standard deviation is a minor violation of an assumption. You're going to have to assume that what you calculate in your sample is going to generalize into what the population standard deviation is. So you have basically the same functions, you have the same process. One's a z-test with a known standard deviation, one's a t-test. So within that realm, you have to be very cautious on how you set up things. I know a couple last term, they had the process going, but they would use Z and T interchangeably in the 7-step process, and you can't interchange those. Once you start with a Z, it's a Z all the way through. You're going to have a Z observed and a Z critical. You're going to have a T observed and a T critical. And you find those critical values differently. And the critical value is that value from which anything that's at and beyond that becomes rejection of the null hypothesis. Okay? So once you find your critical value, and you have a Z chart where I think it's the critical value for a two-tailed test would be 1.96, and for a one-tailed test is 1.64. So those becomes the critical value areas. So you have to make a determination whether you're looking for a difference, which is equal, not equal, or a direction of that difference, which is greater than or less than. So if the question states, I think the question is, the father wants to know if the average weight of his children are no different from the average norm in the hospital. And no difference is a two-tailed test, because you don't care about direction. All you care about is a difference, right? So that would be HO equal and HA not equal. So if you, in the second part, it says the father is concerned that the average rate of his 4 children's birth weight was less than the norm. Okay, less than now determines the direction. And the direction of that arrow goes with the alternative hypothesis. So the alternative hypothesis would be H sum A, U equals, I think it was like 7.2, or excuse me, U is less than 7.2. The null hypothesis is always, always, always equal. Always, always, okay? And then in a one-tailed test, once you make that determination for the alternative, like less than 7.2, then you go back up and adjust the null to cover all mathematical possibilities, because now it becomes greater than or equal to. So the direction of the arrow goes with the alternative hypothesis in a one-tailed test. And so Z, you have a different way of doing it. And then the t-test, you have the student's t-chart. And I think it goes through the process of how you locate the critical value, because you have your sample size, which is n-1, and you look up on the top of the chart, and you see the one-tailed, two-tailed areas. So if it's a two-tailed test, you go where it says 0.05, bring it down and intersect it with the sample size, okay, a sampling distribution, and that becomes your t critical value for that. So this one may be, gosh, I don't even know what it was. So 5.34, I'm just guessing. But you have to be real cautious on the two assignment questions, because one is a Z and one is a T. And I think the first one's a Z test because the standard deviation is given. The second one is a T test because you have to actually, in that sample size, you have to calculate the estimated standard deviation, okay? And you're going to be using the divisor n-1 because you're not using the entire population, okay? So basically in step one, you're looking at determining your hypothesis, and that's critical in any statistical procedure in your research, because you want to make sure the direction that you're going. If you're just looking for a difference, then that's your two hypotheses, HO equal, HA is not equal. If you're looking for a difference, or direction of that difference, greater than, less than, higher than, smaller than, whatever it is, then you're in a one-tailed test. So that's the first thing you need to do. Now, you also have to be aware that if I am using a two-tailed test, all I'm looking for is a difference. Then when I get done, if I'm looking at a difference of, is there a difference between mean math scores of 5th grade girls and 5th grade boys? So I'm looking for is a difference. So, but when I get done testing all of this, and I find out that there's no significant difference, however, the females, the mean score, math scores of girls were higher, that's all I can report, because I didn't test for being higher. All I tested for was being different. So you have to be real cautious on how you report it, because if I would test for a difference, a significant difference in direction, then I could report that the mean math scores of girls were significantly higher than the boys. But if you're only testing for a difference, that's all you can report, because that's all you're testing. So you have to be consistent all the way down. So that's step one, is make sure your hypothesis. Step two is your alpha level, which is going to usually always default to 0.05. And also you can use the funky little term for using a two-tailed test, 0.05 divided by 2. And somebody did find that Superman. Anybody see that? Mm-hmm. Somebody did find, I remember I was watching the old show here not long ago, and I said, I wonder what show that was from, because but somebody actually did find that little segment where Superman split himself into two, and he wasn't as powerful as he was as one. So that was pretty interesting. So that's step 2. Step 3 is your sampling distribution. Here you got to be real cautious, again, because in a z-normal distribution, your sampling distribution is going to be z-normal distribution. Okay. In your t-test, it's going to have a definite number. So if you have 30 within the sample, you're n minus 1, so that gives you a sampling distribution of t sub 29. Okay. And that just helps you keep on target again as you're looking for your critical value. So step 4 is your decision rule, and this is your future. Okay, this is what the future is. It basically says I'm going to reject the null hypothesis if my t observed value, which I don't have yet, falls at or above the t critical value of, which we just looked up. Okay, otherwise I'm going to fail to reject. So all that's telling you, and keeping your mind on target, is that when I crunch all this data, if my observed value is at or above the critical value, I'm going to reject the null hypothesis. Okay. Step 5 is actually the crunching of the data, so you find out your t observed value. Then step 6 becomes your summary, which goes back and it has to follow, it has to parallel your decision rule. So, for example, if my critical value is 1.8 and my observed value is 1.9, I've said in my decision rule that I'm going to reject the null hypothesis of my t observed value falls at or above my t critical value. So now my observed value is 1.9, which is above my critical. So my summary is, since my observed value, t observed value or z observed value, falls at or above my t critical or z critical of 1.8, I therefore reject the null hypothesis. So those two, 4 and 6, have to follow one another. Okay, and then 7 is your conclusion, which has to follow what you did in 6. So 7 is, since I've rejected the null hypothesis, I find that there is a significant difference. A lot of people forget to use that term significant in their conclusion. Oh, they say, well, I have a difference. That's not what, when rejecting null hypothesis, when you are rejecting a null hypothesis, you are making the claim that the data was significant enough to reject the null hypothesis. And that's why when you reject it in favor of the alternative, you have that significant difference. So please do not forget to include significant difference in your conclusions on both the Z and the T, because that's basically what happens. And a lot of people forget to include that. Because again, it's a statistical language, and you have to know and understand what the terminology is. So if I reject it, I've already automatically made the assumption that it's a significant difference. So that's your basic 7-step process all the way through, and it's one that's critical. But regardless of what statistical procedure you use in the future, if you follow this 7-step process, it will keep you on track no matter what statistical application you're going to be using. So if you're using a t-test, use analysis of variance, use a MANOVA, you can use a correlation, any of those funky stats down the road. But that 7-step process is designed to keep you focused on what you are doing. So matter of fact, I just read a dissertation, chapter 4 and 5, from a person who is we've had a long and interesting road, but we're getting down to where she's getting ready to finish. And so, chapter 4, we have to make sure when you get to this point, when you're writing chapters 4 and 5, you are forming the road to the end of the tunnel. And now it's a mere thing of tweaking, make sure you got the right terminology in there, adding to and deleting from all the way through. So understand, this is a process you're going to be going through, and it's going to be full of tweaks and ups and downs, and And it's why it's called pretty much a persistence degree, because those who have the persistence are the ones that are going to complete it. Because you're basically at the mercy of your committee when you go through this. And a lot of interesting things. I told one years ago, he kept arguing. Matter of fact, it was a residency I was attending, and he kept arguing on what he wanted to do. And I said, "You can't. It's not impossible to do, but you're going to be here till you're 104 trying to do it. So let's kind of narrow this down to an area, because your job is to get done with this." And he kept arguing. And I said, here's what you're going to wind up doing. You're gonna wind up just arguing with your committee all the way through. And I told him the story when I was at Mississippi State. I'm standing here, and this guy was arguing with our chair, our dissertation chair. Can you see me? Can you still hear me? I lost something here.
Becoming choppy.
Not very well.
Okay, something happened. Something came up. I just lost it. There we go. Well, my internet connection is unstable. Hopefully, maybe we can get through this. Now, okay, we back? Mm-hmm. Okay, you're back. Hope they loaded everything. Well, anyway, so I'm sitting there in front of this guy's arguing with the chair on what he wants to do, and the chair was saying he doesn't need to do all this, just need to do this, and let's get this done. And he kept arguing. Finally, the chair said, "Son, you just learn to shut your mouth, do what I tell you, or don't let the door hit you in the butt on the way out." And so when he left, and I walked up, and the chair looked at me, he says, "Now, what can I do for you?" And I just looked at him and said, "Anything you tell me to do, sir." And that's why it's a humbling degree, because I came in as a superintendent. You know that, Greg, okay? You have a certain level. I was 28 years old as superintendent, okay? So you have a measure of whatever, and so you learn to humble yourself pretty quickly down there, because these guys know, and this is why I try to tell people, I don't care what your position is in the world, but when you come into a dissertation, you are a novice everything. You're not writing. You don't know how to write at the doctoral level. You don't know how to analyze data basically at the doctoral level. You're a novice at this. And that's what people have to understand is, this is it's why it's a humbling degree too. And I'll tell you what, if it wasn't for that group down there, and I will tell you, everything that I did in my dissertation set the stage for everything, all the successes that I've had, all the publications, everything that I've done has been a result of following that dissertation process, and I was very pleased with that. So, all right, I give you my little spiel on the 7-step process. So I'll open it up for some questions that people might have. Darius, is that how you pronounce your name? Darius, I see your eyeglasses. I can't see your face, so. And you're muted. So. But I'm going to open up for questions, so whatever you have, and
yes, that is my name. I get unmute here.
Okay, Darius, that's it. Okay.
Yes.
So throw out some questions, because I know this is a totally different and new section in stats. As I said, it's probably going to be one of the trying. Actually, this is a trying week, because once you get all the bugs out of it, week 9 is following the same process, except it's correlation. So same water, different jar.
I do see on the chat thing, somebody asked a question about the rounding rules, whether we round at each step or we wait till the very end.
Wait till the very end. It's the last answer.
Okay.
Yeah, that was my question. I think that I've done the assignment, and I guess I was just concerned about at least one of my answers. The first scenario with the z-test. I actually double-checked my answer on an online z-test calculator, and it came out to be just a little bit different from the calculation that I got when I went through it manually. And I think that's because one time I did it, I rounded first, and another time I only rounded when I got the final answer.
Yeah. The only thing you don't round is the critical value that is established and set. Okay. That's nothing that we calculate. That's the research set of numbers that we use to make that determination. So if there are 3 numbers or 4 numbers, we do not You don't round critical values, but you round your final answer for your z-test and your t-test. So you'll have 1.53 or whatever or 8.65.
I was concerned more with the part where we figure out the standard error of the mean. That was the part that I think I was missing.
Okay. Yeah.
We don't round in until later.
On that one, yes. I mean, you're going to use a rounded version of that on the standard error because that becomes the final answer for the standard deviation that you're going to be using.
But when we do the square root of 30, the number is quite long.
Yeah, so you round.
We round first before we compute any further, or how many decimals do we take it to? Because it's really long.
On the all right, let me hold back. So you have the standard error is about the square root of the number. Yeah. I mean, use all the numbers, whatever your calculator is going to take to do that, because your final answer is actually going to be the standard error. So if you're going to use the square root of the number, it's going to come out to some funky long thing. Usually, I'm trying to recall on a calculator doing that because I plug the numbers in, and it automatically calculates everything for me. So
I did notice that different programs round differently automatically, and get a little bit of different values depending on what program you use.
Yeah, it's and that's why I'm trying to get everybody to use Excel all the way through, and at least over the years, people were mostly were very happy because they'd never heard of Excel, and they wound up having a new friend, which in education helps them quite a bit when they're trying to do certain things. And it's a not bad program, but when
so we can
get
trust
into
the Excel number then.
I'm sorry.
So we can trust the Excel number.
Yes. Yes.
Okay. Because when we rounded before on another assignment, Excel was actually giving us incorrect answers because of the rounding.
Yeah, it was. I don't know if it's a different version of what it is. Some people have the brand new version, and some have an older version. I think I have. Oh my gosh, I froze again. Okay, this is getting funky now. I'm gonna have to get my internet provider tell them to. But yeah. Carry out, trust your Excel program. That's all I can tell you right now, because different programs can carry different different sequences, but it's usually awfully close.
Okay, so only round the very final figure then.
Right. Yes. Always round the final figure, and unless otherwise told, it's always 2 decimal places. Okay. And especially whole numbers, because people forget that if you got 35, you get 35.00, and they say, well, that's just so. I don't know what they gave it a term. And I said, it may be, and it doesn't. In some cases, it doesn't matter what you think in stats. This is stuff you have to do in stats, and it's hard to tell individuals that are used to just writing the number down. I said, well, that's fine, but when you're in statistics and research, that's where I say you have to be very precise in what you're doing, and you have to be parallel all the way down as well. So the rounding aspect of it, if you get on an SPSS program, it might give you something maybe a little bit different, but as long as you're within the ballpark, and in the ballpark, sometimes it's people look at it and they go, but if you put this number in before this number, it might give you a different set of rounding errors, and just it's an interesting gig on how to analyze data, and if you're consistent all the way through, that's the big thing.
Hey, Dr. D, this is Greg. Just wondering if everybody else could put their systems on mute. We're getting a lot of feedback from somebody in the background.
Okay. Yeah, if you would put your systems on mute unless you're going to answer or ask a question. That would be good. So,
yeah, I do have one question. As we move forward, are we going to need like SPSS or R or something other than Excel?
Yeah, you will be in Chapter 10 or Week 10. I have a section in there on SPSS, and that will give you some websites on how to work SPSS, and I think that's the formalized statistical analysis package that the university supports. So SPSS is a statistical package for social science, and always there are two things when you do research you have to understand. The term data is plural. Okay, I always tell a novice researcher when they go, well, data was, no, it wasn't, data were. Okay, so the term data is plural, so make sure you understand that. The second thing is when you write in your dissertation the data were now analyzed by SPSS, that's fine and dandy. There's like 97 versions of SPSS. Just always put the current version of SPSS, and you're always going to be correct. Okay, so if they go from 7 to 8 while you're doing your dissertation, in your dissertation itself, your data were analyzed by the current version of SPSS. So, unless your committee is anal and they want you to actually put the funky 97 letter code of the SPSS package. So, but yes, SPSS is going to be the package of choice for working. And I've been suggesting over the years that they should have an SPSS week-long training seminar somehow. Put it up there, and in lieu of that, that's why I put up the different links on the web. So it'll show you how to, basic SPSS, how to analyze. One's going to have just analyzing the central tendency and measures of variability. One will do a t-test. So hopefully it'll kind of give you an idea of what it is. And I think the university has a a system to where you can purchase a student version of SPSS, because it's pretty expensive to get. And hopefully the university might have just a site where you can go and analyze and download some of those things. So, but that's the power of it. And I remember I can remember the day when the SPSS program that I had was a mainframe, and it was in one building. And the research community, when they went to PCs, the research community would not accept data that were analyzed on a PC because PCs were pretty new. So the research community, if you put, I analyzed my data on a, desktop or something, they wouldn't accept that as credible. So it had to be through a mainframe. So now it's pretty much, you can analyze it on your phone, and on SPSS. Excuse me. Okay, what else?
I'll go. Couple questions. One, okay, so when figuring in the confidence intervals for a t-statistic, and we're using the n number, the sample population, we still use the entire sample population number, right? In that, when we're figuring the standard error. So if it's 30, we still use 30, not the n-1, or do we use the 29 figure?
No. The 29, the n-1 is only for your critical value.
Right. That's
okay,
what I
so
thought.
Your sample, so your formula, you're going to be using the entire sample size.
Got it. Okay. Well, okay. I thought so.
Yeah. So the n-1 in it's all a statistical function of nobody knows why, but if you have 4 numbers and they all have to add up to 30, the first 4 numbers or the first 3 numbers can be whatever they want to. Okay, but the 4th number has to be specific.
So the
so it equals 30. So you lose a degree of freedom.
Only for the student t-test database.
Breaking up. I'm sorry, I couldn't hear.
So the n-1 then only comes into play when we're looking at the data table for student t-test.
Yes, but also in your formula as well. When you actually calculate, you calculate by hand. It's going to give you a. We have to look up the different values there. For a two-tailed test, for example, your sampling distribution is going to be the addition of each of the groups. So it'll be 30 minus 1 is 29 plus 30 minus 1, 29. So your t distribution instead of t sub 60 is going to be t sub 58. Okay. So that's determining your critical rule there. If you are really excited about doing a t-test by hand, which I hope everybody has made a determination that plugging values into the computer is a far easier process than having to do it by hand. It will calculate everything for you. Also, I think in the next week, I think it is, there's a thing called a p-value, or is it this week? Can't remember. It's p-value is the probability value, and that's one of the first determinations, or actually maybe it's in stat 2. But anyway, you get a p-value, and a p-value is a probability value. It's all calculated through SPSS. That one is if the p-value is less than or equal to your alpha level, you have statistical significance. Okay. If it's greater than your alpha level, then you have no statistical significance. So p-value is your first indicator of statistical significance. And that's and people reverse those all the time too. So if it's less than or equal to your alpha level, you have statistical significance. If it's greater than your alpha level, then you have no statistical significance. So that may be coming in the next course, but I may allude to it in this one as well. So there's a lot of interesting things as you analyze data through the statistical programs that they reveal. And you can check. I use a program. It's called StatView. It's only one. It's the same thing as basically SPSS. It does the same things a StatView can do, or SPSS can do a whole lot more. But for my intents and purposes, StatView is one that is very simple to use and gives me the results that I want. So you can ask your committee if you can use a program, if you're comfortable with another stat analysis program, to use anything other than SPSS, unless it's a university requirement on that. So there's only a few that out there that are that's going to be recognized as something that can be used in research. So you just basically just check with your computer committee to make sure that you can use the program. I think what you find once you start getting comfortable with the 7-step process, it becomes extremely easy to start analyzing data after that. And that's why most people struggle in week 8, and they do well, they do okay, but week 9 they usually come through flying colors because now they're used to it. I say week 9 is a correlation; it's the same process, only you use different symbols, and you're going to have a different critical value chart. It's the Pearson's chart that you can be using. So. Stat 2, or the quantitative measures, the next class, stat class, is a continuation of this. So we're going to be going into, instead of a 1-sample Z and T test, we're going to be going into a 2-sample T test, independent variables, and the one-way analysis of variance. So basically the one-way analysis of variance is nothing more than an extended T test as you go through this. So, that's a lot of fun. But 7-step process still follows no matter what you do all the way through. So, other questions? How many have I got here? I got 9. That's pretty good for the first go around. As far as the course, I'm sure that somebody is going to, in the back of the brain, this is one of the most challenging courses, and I tried to explain that at the very beginning, that it is a challenging course, but usually there's one or two that just has a mindset of, I'm not going to read the announcements and I'm just going to put up anything. And I'm still, in all the years that I've done this since 1990, I'm still trying to figure out with the mindset of, you need to follow directions. If you follow directions, you get through this. I can get you through this. And there's a lot of things that I do in this course that kind of people kind of take a look at and they go, why are we doing this? And it's only preparing you for what's going to happen with your committee, because the committee is going to come back and they're going to make all these changes, all these modifications, and you can't just do what you want. I mean, these are very precise. Okay, Rosemary has a question. It said, put that up again, Rosemary. What's the difference between a benchmark and the final exam? Um, one on the facetious side is one you get graded and the other you have to pass. One you get one try and one you get three. Benchmark is a compilation of your first research course and the stat course. Okay, so there's going to be questions on there dealing with your first research course that you had along with this course here. You have 3 chances to pass that to get 80%. At some point in time, if you don't pass it and if you don't get the 80% in this class, then you'll just have to sign up for a special something. I don't think they charge you for it, but it's nothing more than just taking the benchmark all the way through until you do pass it. All right. The final, you get one shot at it. It's a one-shot system. And the reason we went that route instead of like a benchmark is that some people in the benchmark can go through the first time and kind of get an idea of the questions they missed and know that the answer they put down was wrong. And by the third time, you know, they should get it right. So we made the final one-shot deal. That's why I'll send out some announcements on how to prepare for it, how to get your mindset, because it is a if you're not prepared, if you get distracted during it, I mean, it's a time. I think you have 3 hours to take it. It's not overly difficult. You have all the material in front of you, but the questions are worded in I would say humorous ways, different ways. In other words, there's one that says I'm trying to think of one. There's one, Poindexter scored this on his exam compared to the national norm. When all is said and done, you have 4 answers, and Poindexter is really great, should be doing this. Poindexter is this and that. Poindexter should not be hired by the Defense Department, falling 2 standard deviations below the norm. So, you know, people look at it and say, why are you doing that? Because when you analyze research, you have to be able to look beyond the crazy stuff and find out what is actually being said. So you throw all this, Poindexter should not be hired by the Defense Department because of falling 2 standard deviations below. That's the part you're looking at, 2 standard deviations below. Everything else is meaningless. And that's what you have to look at in research questions or research articles is what is camouflage, filler, and what is stuff that's actual, that's going to give you the credibility and stuff to analyze. So as you go through this process, you know, in the final exam, you have to look at what is important in the question and what is important in the answers. And, you know, it's a different type of thinking. And again, we didn't put as much weight on the final exam because it's a one-time shot. But it's something that if people don't prepare for, I've seen them drop, you know, a letter grade. I've seen 90s and I've seen 20s. So it's really
400 points or something, isn't it? Isn't the final exam a massive amount of points? 400 or something, I think.
Unless they changed, I don't know exactly. I have to go back and look because right before every exam, I go back and take it to make sure that all the answers are correct on there. I had this as a bad feeling as a professor when they upload a course. Sometimes they forget and they go into an archive and they upload an older version, which is what one person sent me. He said, "Well, I told them there were 4 two-tailed tests in the I guess in the last assignment dealing with sample size." Well, they uploaded the wrong version. Okay, so now I had to go back and say, okay, that's why I sent the email. There are no no one-tailed tests in there because they uploaded the wrong version. So, Can we do a review prior to the final exam like we are doing tonight? If I can find the time to do this. Yeah, I'll check my schedule because that's in week 10. That's 2 weeks down the road. I will. I'll see if I can, working in my schedule to get an hour in there for people to come back on. I may get more people since it's a review of final exam and see what happens with it. And by then, I'll take a final exam, make sure all the questions and answers are correct.
Yeah, if we were going to do that, I would think we'd want to do that not at the tail end of week 10.
No, I was looking at. I have to look at my night schedule because I do teach a couple of night classes for local university here in environmental science. So it's kind of my out course, kind of relaxation, the environmental science aspect of it all. So I do have a bachelor's in geology and a master's in environmental science, so I enjoy the environmental aspect of it as well. I was actually out on an oil rig here a year and a half ago in Wilson, North Dakota, working with an oil company. So that's really freaky when you're doing that, sitting up on an actual oil rig in the fracking industry. So, but yeah, I'll send an email out or an announcement and see if we can see if I can come up with something. See, next week is week 9. Either the latter part of week 9 or the first part of week 10. See if I can come up with something. I may do it the weekend of week 9, so I give you the whole week to figure all this stuff out. The big critical thing on all this is that both the benchmark and the final exam have to be done before whatever the program closes on Sunday, week 10. Because once the program closes, you have no access to the final exam and you don't have access to the benchmark. So if you don't take the final before the class ends on Sunday, whenever it does end, then it goes down as a 0, and I have no control over that. So same with the benchmark, and then it goes down as you didn't pass it, and you're going to have to sign up for the benchmark class. So I will do that. Getting close to, I think we got about 8 minutes left in this session. Has this been helpful? I mean, this is my first go around, so I'm just kind of feeling my way through, taking questions and everything and trying to explain.
Yes, it's been very helpful.
Okay. As I say, my goal is to make everybody successful. It's not to fail everybody, and that's one of the scenarios that when people, if they look at an on-site stat class taught by a site prof, I mean they are not compassionate at all. I mean, you screw up, you're done. I mean that's just the way it is. And but I took stats under a psych prof in Mississippi State, and when I went into it, the department told me nobody ever got an A out of this guy. And I said, well, I'm going to get an A. And so my first 3 tests were C, D, and a C. And so I went to talk to him, and I said, I don't understand. I'm not totally stupid, but something's just not happening here. And so he wrote all this stuff down. He says, well, if you do all this stuff, then you can get a B. And I said, well, I want a B. I want an A. And he looked at me and said, that's your problem. Your focus is on the wrong thing. Your focus is on the grade, not on the content. So I told him, I said, well, don't tell me what I'm getting unless I'm failing. And I wound up on the final exam. His thing was all the average of all the tests or the 4-hour final exam, whichever was greater. So I went in to take the final. He handed it to me, and I looked at it, and I started going through it. And I said, well, I know all this stuff. So I wound up getting a 92 on the final. I got an A for the course. I took him for Stat 2, Stat 3, Research 1, 2, and 3. And that's why I put at the beginning of the course is if you're concentrating on keeping your 4.0, your focus is on the wrong thing. And you're going to look at ways of complaining on a point to keep your 4.0 rather than trying to understand the material. So, all right, question came up. Where can I find the template? Is there one for this week? Did I not load a template for this week? I thought I did in the announcements.
What you gave us a template for the 7-step process. We put that in for each of the 2 first problems, right?
Yes. Yeah, that's the template for that you just copy and paste. You use one for the Z-test and one for the T-test. Hey, I kind of like this. I may incorporate this in each of the classes now. So now that I know how to run Zoom. And it actually worked. So I've lost 2 people, so evidently they're beyond feeding time. So all right, let's see. I got I wonder what this thing is. Oh, there's chat. Oh my gosh. All right. Templates. Very. All right. Good deal. So now I see the Zoom chat. Wow. I've learned something tonight on this. So any other questions on this? Rosemary, I got to look at your eyeglasses all the way through this. No, I can see your face. I just see the top part of your face. Oh my gosh. So, there you are. Okay. So anyway, this is, when you get through this course, I have a special certificate for everybody that I'm going to send to them, and it's Stat Survival certificate. And you can
Does it
hang
come
that
with a
on your
beer?
wall. Huh?
Does it come with a beer?
No, but it may shortly. So, but anyway, if there's no other questions, I thank everybody for coming on. I will put up the recording. I think if I know how to do this right, it'll download it, and I'll put up the recording of all this on YouTube, and people can kind of look at it and see what's happening all the way through. So,
Okay. Thank
all right.
you. Cleared up details.
Have a great
Thank you for your time.
night.
Thank you,
Take care.
Dr. Demolin. Thank you so much.
Take care. Have a great evening.
You too.
Bye-bye.
Bye.
Okay, pause and